There's a lot of exciting stuff that I want to share with you in this devlog, from the work-in-progress pedestrian system to the stunning new buildings that I got from Unreal Engine Matrix demo. And I also want to share my experience with ChatGPT and how it actually helped me overcome my wall running issue. So at the moment the NPCs are not very smart, so I decided to fix that. I explored a lot of different approaches and ultimately decided to use a spine object which will be used to place points along its path for the NPCs to detect and follow. This way I have more flexibility in setting the paths fast. The spine objects themselves can be removed afterwards since they're not needed anymore. And I'm also trying to keep the points themselves as lightweight as possible to preserve performance. With NPCs now able to detect and follow the path points, it was time to take the next step and introduce the spawner object. Their purpose is to seamlessly spawn an X amount of NPCs and reallocate them around the map, ensuring they're always in close proximity to the player. This is done by placing them all over the map, which will check if the player is close enough to them, and if so, they will start spawning NPCs. I followed Code Like Me's series on Pedestrian System, so thank you so much. However, I did encounter a few obstacles that I had to overcome on my own. The series, while informative, seemed to have a flaw in the actual reallocation logic, and it's also very important for the system to be fully compatible with multiplayer gameplay. And so, after a day or two of reworking the design and debugging, I had a work-in-progress solution which reallocates NPCs only around the host player. One of the changes that I had to do was to move part of the logic to a separate NPC manager object, which is a type of game state, which in simple terms is used for managing all the information that should be known by all players. This way, the spawners can have reference to all spawned NPCs and those NPCs that are available for reallocation when they're too far away from the player. If you're looking to deepen your understanding of how multiplayer works in Unreal, highly recommend checking out the compendium. I'll leave a link in the description. And it was at page 9 that I came to that decision to move the logic to the game state object, as both the host and the clients have access to it. As a bonus, I played around with the AI perception component, which simplifies the way AI perceives data, and I managed to add the logic for the NPCs to react and run away when the player uses his ability to transform. In the meantime, I was also working on the environment, but rather than using procedural generation, I decided to build the world manually. I began expanding the map, adding roads and buildings and other different assets, like these lamps for example, which break when the player collides with them. I also experiment with Unreal Engine 5's new world partition system, which allows for disabling and enabling different areas of the map based on the player's position. However, as expected, it didn't quite work as intended while testing it in multiplayer. For the assets themselves, I've been using some amazing ones from the Unreal Marketplace, but one day while watching an Unreal Engine 5 YouTube video, I noticed something interesting. See, when I experiment myself with Unreal Engine Matrix demo, I was thrilled initially because all the assets used in that project are exactly what I need for my indie game. But soon after, I gave up on that idea as there were too many issues, like, for example, the buildings themselves. Instead of it being one whole object that I can just copy-paste, it consisted of 1,000 smaller ones, which would make it impossible for me to reuse in my game. Now looking back at that video, do you see it? Yes, it's an example level with all the available buildings as one whole object, and that was perfect for me. And without a second thought, I re-downloaded it as fast as I could to give it another go. And to my surprise, everything worked great, and I managed to finish my game and publish it to Steam. And what? The buildings don't have collision, and it's made of 1,000 small objects, meaning do I have to go on each object and enable the collision one by one? I thought there has to be a better way to do it. And thank God I did a quick research before, because I found this option which allows me to edit a bunch of assets all at once, which is amazing because that saves me a lot of time. Eventually I did solve my collision issue, but I realized I had some fundamental issues with my wall running logic, which I had to fix next. Before getting into that, I want to talk about the player movement. One of the first changes I did was the impact effect while landing. I did this by having a timer start counting as soon as the player is in the air, and on the landing part, I multiply my visual effects by that amount. At one point I will add also a pushing force on the landing to push the NPCs away. And now for the juicy part. ChatGPT. Obviously my wall running logic was not finished, so I asked ChatGPT how to implement wall running in Unreal. It gave me different answers, some in C++, some in Blueprint, steps, and I was excited and I was trying every single thing it was recommending me, but I would never actually get the result that I needed until it recommended me this function. This single function saved my wall running logic and allowed me to fully move the player perpendicular to a wall based on camera's direction. I also switched the static gliding animation to a dynamic one using the falling speed of the player. If you've made it this far, you are amazing. And why not check some of my other videos? Thanks, and see you in the next one.